Finally, we get to the final three functions, the cosecant, secant, and cotangent functions. Skipping over to the cotangent function looks very similar to the tangent function, whereas the red dotted S shapes are the tangent function. The blue solid are the cotangent function. So notice that they are decreasing from left to right. One of the big differences is where the asymptotes lie. The asymptotes lie every 180 degrees on the parent function, and the way you would find the asymptotes is simply take 180 divided by the absolute value of b. And no reason to do odd multiples of it. It's just going to be every 180 divided by the absolute value of b degrees. The rest of it is very similar to that of tangent. The range is all real numbers. The domain is wherever there's not an asymptote, there is no amplitude, and the period is 180 degrees. The secant and cosecant functions look fairly complicated. I'm going to go to the cosecant function at the far left. The cosecant function is related to the sine function. So the red dotted line is actually the sine function, and those blue U shapes opening upward and opening downward are the actual cosecant function. What the U shape, how the U shapes are created is that notice that the bottom of each U shape that opens upward, like this one, touches the top of the sine function, and the top of each U shape opening downward touches the bottom of each point of the sine function. The asymptotes, as you can see, are located where the sine function has an x-intercept, like right here at 180. And there's an asymptote right here because the sine function has an x-intercept at 360. And the reason for that is, remember, sine and cosecant are reciprocals of each other. And if there's an x-intercept, that means that there is the y value equals 0. If the y value equals 0, that means the opposite over the adjacent side, the opposite over the hypotenuse, we're dealing with sine, must equal 0. And that means the opposite side must have a measure equal to 0. Well, if the opposite has a measure of 0, when I flip it over to hypotenuse over opposite, I have just placed a 0 in the denominator, which is not possible. So that is why everywhere there is an x-intercept in the sine function, the related cosecant function will have an asymptote. Since sine and cosecant are very closely related, you'll see that their the period is related closely. It's at 360 degrees. There is no amplitude, and the domain is wherever there's not an asymptote, and the range is going to be, for the parent function, less than -1 or greater than 1. Since it's always going to be opposite over hypotenuse, since always going to be hypotenuse over opposite, and the hypotenuse is always the largest, that means that it's always going to be greater than 1 or less than -1. And you'll see that the secant function is very related to the cosine function and has those characteristics. So in order to graph a secant or cosecant function, what we're going to do is we're going to graph its related sine or cosine function first. Find the period of y equals 2 secant of theta, then graph the function. So the period is going to be found just like it is with sine or cosine. It's going to be 360 divided by the b value. The b value is 1, because it's the 1 right in front of the theta. So the period is 360 degrees. And since the period is 360 degrees, then we are going to graph the related, since it's secant, we're going to graph the related cosine function, which is y equals 2 cosine of theta. So reviewing how to graph 2 cosine of theta, since we have a period of 360 degrees, and since it's cosine, it will start at the highest point of the amplitude, which in this case is 2, and at 360 degrees, it will be back up to 2. We'll hit the low point at -2, and then halfway between the low points and each of the high points will be our x-intercepts. So this is one full cycle of the cosine, and then a second cycle would end at about 720. I'm going to go on off the graph a little bit. And here would be a second full cycle, hitting at 630, then back up. And back on the other side, it's going to hit 90, down to -180, and so on. It's about like that. Now, that is the cosine function, but we're supposed to be graphing the secant function. So, anywhere there is an x-intercept, there is now going to be an asymptote of the secant function. So everything related to the secant function I'm going to do in blue. So we will have asymptotes located here and here, because every time it crosses an axis, we're going to have an asymptote. And we can do this as many times as I so choose to do it. And that's enough for me. And then we will start drawing these U-shapes. Now, they're not quite parabolas. They're a little bit flatter on the bottom than a parabola, but they are going to look about like this. So the blue U-shapes are the actual graphs of the secant function. Find the period of y equals cosecant 2 theta, then graph the function. So, since we're going to graph the cosecant of 2 theta, its related function is the sine of 2 theta. We first need to find the period, so the period will be located at 360 degrees divided by the b value of 2, which is 180. And then we will graph y equals the related function sine of 2 theta. Has an amplitude of 1 and a period of 180. So sine starts at 0, 0. It ends the period at 180, and I'm going by 15s on each block this time to spread it out a little bit. And at 90 degrees, it will be back at the x-axis, reach its high point halfway between the intercepts and the low point halfway between those intercepts. So here is one full period. And then let's see, at 360, which would be about right here, it will finish its second period. So at 270, it hits the x-intercepts again. 225, 1 is the high point. And then about 330 is going to be the low point. So there's 2 full cycles, and I can do that on the other side as well. So -45 will be a low point if I continue the pattern, so roughly like this. Switching over to blue now. Now I'm actually going to graph the cosecant of 2 theta. So wherever there is an x-intercept, I will have an asymptote. And that includes the y-axis in this case. And right here. And right here. And right here. And about right here. So I'll draw my U-shapes between the asymptotes, touching the low and the high point of each peak and valley. And you can do that as many times as you wish. At least 2 or 3 times, I should say. I just don't want you to do it one time and say, that's all I wish to do. And that would be a good representation of this cosecant graph.